Hello, everyone that's jumping in. We're going to give a few minutes here for everyone to get into the webinar. This is Alex from GME Supply. We're working with Jeremy and Tony to kick this off, but in probably 2 or 3 minutes, we'll get things started. All right, it looks like we've got a decent group here. For those that didn't hear the first announcement, we are going to get things going. This is Alex from GME Supply, and we're partnering with the Texas Wireless Association. I'm going to hand it over to Jeremy and Tony, and we'll get this presentation going. Thanks for joining.
So good afternoon, guys. For those that you don't know me, my name is Jeremy Baldwin, and I'm a business development manager with Diamond Communications and serve as the Vice President of Texas Wireless. Today is kind of the start of an educational series that we'll be putting on quarterly to add some value to our members and sponsors of Texas Wireless. Texas Wireless, we're happy to have Tony Sabatino from Diamond Communications speak with us today. Tony's the Chief Strategy Officer with Diamond and has 30+ years of experience in the telecommunications realm. He's also worked to help build the first nationwide network under Sprint PCS and has several patents in the telecom space. So Tony is here today to discuss how satellite communications are evolving and how it plays into our wireless space. Hopefully everybody can see some value on this topic. We'll have some questions, kind of chat as we go along, but I'm going to pass things over to Tony now. We'll get this thing started and get it moving. Good afternoon, Tony.
Yeah, thank you, Jeremy. Appreciate that introduction. For those of you that don't know, I've been kind of started from 1G to 2G to 3G to 4G to 5G, and kind of we'll see maybe 6G advanced, and maybe I'll start fishing after that or something fun. But I appreciate the opportunity. The reason we picked this topic today is there's been a lot of questions around what satellite can and can't do today and where it's evolving. And so we've got an attempt here to kind of walk you all through and discuss where we're at today, a little bit of nomenclature. By no means is it a continuing professional engineering study business unit level, but it will give you some good visibility so you all can answer questions in whatever facet you are in this particular business. We'll talk a little bit about fixed. We'll talk a little bit about wireless. We're really going to kind of see some things that are going on. I'll peek a little bit into what T-Mobile's announced with their SpaceX and Starlink program, how they're going to be doing a nationwide model, but also looking at what's coming on with the iPhone 14 as far as what's the Snapdragon Qualcomm chipset and what that enables. So with that, Jeremy, if you can just go to the next slide. And as Jeremy said, the chat's open, so if you have questions, Jeremy will monitor that and then kind of get me on the chats as I'm going through this. So there's really been a great amount of kind of discussion around satellite for broadband and what's available out there. And three big players in the commercial market today are companies, and I'll show you this. You got Viasat, you've got Hughes, and then you have Starlink via the SpaceX partnership. And that's really what we're going to drive. We're going to give an emphasis on satellite and the end users and what's real out there and what these systems are capable of. So next slide. Okay, so obviously you have choices for landline. You still have the old digital subscriber lines, which is truly data over telephone lines, copper systems and all, and they have certain capability. And I'm going to show you the DOCSIS for coax. I'm going to show you the levels of what kind of capacity these types of technologies can produce in a few slides later. Then you have the hybrid fiber coax, which is kind of a broadband network. A lot of the cable operators utilize this. And then pure fiber, the optical fiber that we've seen. Pretty much there's the GPON, which is the passive optical networks, and then you have XPON, which is different variations of that. So going to the next slide, we'll look at the choices for wireless. I'm only going to stick to, you have mobile broadband that we kind of talk about, and we'll talk in a second about that. But fixed wireless access using kind of home cell site is available in both 4G and 5G. What's tremendous about where we're going at today, if you look at the commercial wireless carriers today, the big names, the big four, inclusive of Dish, and then if you look at the regional carriers like US Cellular and other brands like that, whether it's Pioneer or somebody else like that in the smaller markets, what you're seeing is fixed wireless systems in what we're calling the new band, the C band, or the EBRS, BRS, that 2.5 spectrum that T-Mobile uses. These frequencies avail a pretty extensive amount of spectrum, anywhere from 60 to 100 megahertz of spectrum, which gives you capabilities where a cell site can really push out well over 4 or 5 gig in a wireless point. And you'll start seeing the wireless availability of those technologies moved into a fixed wireless home. What that means, if you may have seen some of the advertisements by some of the large carriers of bringing, Company X mobile home hub, mobile home broadband, and there's been some good subscriber growth on using fixed wireless. And what fixed wireless is really is, in a lot of cases, to really get the good coverage, you use a commercial wireless cell site, and you use that to go ahead and bring in a broadband capability. The FCC is really defining broadband now from a wireless perspective of 100 megabits down, and we like to see 25 up. Some cases they're calling for a symmetric level. All right, Jeremy, next slide. Okay, so now we have satellites, and are satellites going to be able to compete with what's out there from fiber? No way. It's just not going to happen. Are satellites able to compete with what we're seeing on the commercial wireless networks? Not exactly, as far as the bandwidth throughput. But satellites are getting importance in the digital infrastructure, provide connectivity to rural and remote areas. And I'm going to talk a little bit about that, specifically to places that don't have connectivity currently. We do some things in the national parks. There's areas that people would love for us to get to. It will take many years for us to get approvals and capabilities. So there are availabilities to do that, but it comes with limitations. And if you look at it, the companies that are the most advanced in the number of satellites is driving that. We'll talk more about the SpaceX Starlink model. All right, next. So if you kind of look at the broadband options, what I've done is I've given you some average speeds of these particular technology. If you look at wired, kind of where the downlinks are and the uplinks are based on these systems. And these are rough numbers. I mean, you can always get better than that. But if you're looking at what we're delivering really for the end user. Now, keep in mind, if you kind of look at the wired system, I've got fiber at like a 10, low latency, 10 gig downlink, 10 gig uplink. Fiber's clearly much more capable, much more of those better levels. However, what happens is that on the consumer side or the end user outside of a commercial business or a commercial operator like one of the wireless carriers, this is typically what we're seeing. On the fixed wireless side, what we're seeing with 4G technologies versus 5G technologies, these are what we're seeing. 5G is going to get even to lower latencies as we go through different releases. Today, in the 5G technology, we're looking at what we call release 17, release 18, 19, 20, and 21 will probably be 6G, really, 5G release 21. But these kind of show the downlink capabilities of what we're seeing today in these technologies. And then as you move to satellite, these are basic levels. And the way you get more capacity on satellites at end user level is really you just have multiple antennas integrated into that home point. I will tell you these are pretty much consumer levels. I will say that Starlink does offer almost a 700 megabit per second downlink system out there. That's only for specific commercial customers. So keep that in mind. Okay, next. So if you kind of look at, and by the way, this shows fourth quarter of 2021. This is an Ookla Speed Intelligence study. It hasn't changed. As a matter of fact, as you get more subscribers and not many more satellites in the system, you're not going to gain a lot of download capacity. So these numbers are pretty good still today on what you're seeing. So if we kind of look at this, if you kind of look at the SpaceX Starlink model, you know, you're going to see downloads. You could probably get 100. The average that we in this particular study you saw as high as 104 megabits per second downlink coming from SpaceX Starlink. You talk to anybody that's using it today. In congestion times, you're probably not going to see that on a speed test, but your upload's about 12. Hughes, Viasat, and then if you can, and I'll talk about all fixed in a minute. You're seeing that though they're much lower, and it really has to do with the type of satellite they're using. Whether, and I'll talk about geosynchronous, low orbiting, and then the higher orbiting sites. All fixed wireless on this during this particular study, and those fixed wireless could be some of the systems that were like using a T-Mobile early home hub back at this time point. This is what you would see, and you can see with using the wireless systems that we know from our cell site perspective, it was providing a pretty good system. This would go back to hotspots and things like that are available. So this is just a view of what we've seen. These numbers aren't that far off today. Okay, Jeremy? So the satellite view is typically portable and nomadic, not handheld as we looked in the previous years. But coming into 2023, handheld's coming to life, and I'll explain that. So if you look at, there's been some early announcements. The iPhone 14 is now enabled with what we call the Qualcomm Snapdragon chipset, and that will be able to access the Globalstar satellite system, but it's for emergency SOS service only, right? So you can only use the SOS emergency service when there's no service. It'll lock on. That Snapdragon Qualcomm chipset is capable of communicating over that satellite system, but it's for emergency use and it's text only. Moving into what we're seeing with T-Mobile, I'll talk a little bit more about what T-Mobile's launched about, and that's going to be utilizing the capability. So I'm going to put that to the side and tell you what's going on the mobile handset side for T-Mobile. What this is the point I really want to make is satellites are coming to handsets in the future. It's just they're really not readily available as far as a communication device today. That's how it is, except for like an emergency text model with the iPhone 14 model. Android hasn't really gotten big on that yet. We were surprised that the new Galaxy, I think it's the 23, it didn't even indicate that they're going to have the satellite capability in that Android platform, which is somewhat shocking. So, okay, Jeremy, next slide. Starlink, they're the 1,000-pound gorilla in this space right now. They're using advanced satellites in low orbit. It will enable video calls, online gaming, streaming, and all, but you saw the throughput levels that we're starting to see. But there's some news around what's going on. They're really driving some good level of capacity. We haven't seen anything near the 200 megabits on the consumer side. On the business side, it is available. They call for 40 milliseconds of delay. Realistically, we're not seeing anything close in the trials and the systems, whether it's Ookla speed tests and all. They're more in a 300 milliseconds. So the latency is still an issue. And keep in mind, you're going. Typically, SpaceX deploys these Starlink satellites at about 260 miles. And you've kind of heard some news about the Falcon 9 rocket having some issues, but those things work. It's the real launch is going to be coming with the next generation of these satellite systems for Starlink. Okay, next slide. So what I wanted to do is talk about the product that's out there today. This is a little bit dated, but I'll give you some. The service is really being kind of rationed until SpaceX can get their next round of satellites in. They're called Gen 2 or V2 satellites. You know, like I say, the service is up to about 300 megabits per second, but we're really not seeing that. Near broadband latency, no data caps for SpaceX is what they offer. But when you buy the Starlink system, it's usually costing you like $600, and the installation costs range anywhere from $300 to $1,200 to help put that in. again, depending on how high they have to put the antenna and all. And the service is about $100 a month, and then it can be portable, which means they know where these systems are. So if you move them, they're going to hit you for this portability where you can go. Maybe you summer in the mountains and winter by the ocean. You can do things like that because the system's pretty simple. I've got a little picture to show you that. Global capacity for Starlink, really as it is right now, can support about 1 million simultaneous users. And if you look at where they're at today, that's what they believe they have, is about 1 million simultaneous active users at one time. And I've got more details to kind of walk you through that. Next. Okay, so they have if you look at a Starlink network, and this slide won't be very long, you have a user terminal. So at home or the place where you're driving the Starlink connectivity, you have a user terminal, which is really an antenna system that's either mounted on the wall or in a place for good location. Typically, they're about 18, 20 feet on the side of the house or the side of the building or on a pole or whatever. The satellite system, of course, is out there, and it's usually running in the KU band, which is 12 to 18 gigahertz system. And then you also have KA, and you'll see the different bands they operate. Typically, mostly KA and KU bands are the bands that the satellites are using. And then there's a ground station. The ground station takes the satellite and ties it. It's got fiber tied to it. Think of it about like a central or a hub or a data center for us in our wireless communication world. Okay, next. So here's just kind of a nice pictorial. And if you look at this, this really kind of shows, if you'll notice on the left, we've got 50 ground stations for Starlink. I think they've added a few more. And the uplink and downlink is all KA, KU, and some V-band. And some are usually V-band is control system. KU and KA is really what I can bearing traffic that's being utilized, what the end user is going to have. So all the communication, the satellite has to be tied. These ground earth stations connect to what I consider the public network, the web, and the cloud, as you would call it today. You have reverse link and uplink capability. But if you kind of look at it right now, the FCC has approved Starlink for a total of 7,380 satellites now. There's less than 4,000. So originally it was 4,408 in the original filing. The FCC recently, in the last 6 months, approved another almost 3,000 to go up to go ahead and redeployed. These satellites also burn out. The satellites are about an 18 to 24 month life, and they fall out of orbit. And they just pretty much disintegrate as they come down. So it's always been a model of low orbiting. There are a lot of these in the country, and I will show you a snapshot slide of a view on how that works. So what is satellite system? If you're interested individually, you just go to Starlink's site on the website, and you can see where the active satellites are right now. It's kind of fun to do. Next slide. So satellite space is heating up. If you really think about the big players on the model of who is out there, it really is Hughes, Viasat, Telesat a little bit. You've got OneWeb, you've got Boeing that has some of these systems out there, but Starlink is the true consumer-facing model that's out there today. And the potential, they really, if you look at their original filing in the model, they believe globally they need about 42,000 satellites. I don't know if they're ever going to get all those approved. But if you kind of look in the upper right, what I'm showing you there, well, let's just talk about latency, the model of the frequency bands and all. Most everybody's in the KA, KU, or V band that's there. Pretty substantial level, but they're really looking at this global level. And Starlink has probably got the most positive press with what they've done in the Ukraine, in the ability of shipping Starlink systems as during the conflict out there that the communication has been pulled out, where Starlink devices have been allowed. The Ukraine to continue to communicate with the world without a reliance of a local central office or hub. This system has really made that capable. If you look where we're at today and the number of satellites and the capability of these systems, I use the example on the top right, and it says data rates available from Ireland. The reason I use Ireland is because it's very important to understand there may be 4,000 or maybe 7,000 or maybe 10,000 satellites in orbit. But at any given time, you really need to concentrate on how many satellites of those 4,000 are serving the geographic area. And so what this study that was done in 2019 was a view. It said at any given time, how much data is being allowed, or what is the data rate available in a downlink perspective to Ireland. It was 72 satellites serving Ireland, with a capability of 1.2 terabits per second. Not too bad, but it just shows you with these low orbiting systems from SpaceX what's available versus what OneWeb and Telesat can deliver. You can see there's massive amounts of capacity available to an area of Ireland. Now, if you spread that across the level of people there, it's a different story. So what I've done is I've taken the Ireland study and I've brought it into the US. Next slide. Okay, so if you go ahead and look at Starlink frequencies, we kind of show the different frequencies and how they go ahead and do communication between the systems, between the different bands. And this just gives you an idea. I've been asked this before. So, you know, the user terminal to the satellite, what they're preliminary using, the gateway link, these are all communication pieces. So what pieces of that previous slide I showed you with the satellite, the ground station, and the user terminal, this kind of shows you exactly what they're using to communicate through different systems. And some uplinks and downlinks could intermix. So this is a reference slide of the different types of satellites. And if you look at the top of the page, you have the low orbiting is kind of the main model, the low Earth orbit satellites. This is where you're getting a lot of the capacity, a lot of the lower latency capabilities because of the path distance. Like I say, you can go up to 1,000 kilometers, or if you do the math, it's 600 miles. But most of those low Earth orbit satellites run about 260 miles. Most all the SpaceX systems launch at about 260. And in the news, you may have seen that with SpaceX, one of the recent problems is they're having is stabilizing and keeping those new higher payload. They're about 3 times the weight of the new generation 2 satellites within orbit, and they have to stay stationary in the orbit. When they find that orbit, stationary means stationary from the orbit perspective, but they're geosynchronous, which means they go around the Earth in a path. And this is kind of being a challenge for them as they kind of look through this. But a large number, LEOs are made into constellations. Those constellations are like chains of these systems. They communicate to each other, and they also communicate to the ground station, and they also communicate to the end user, the user terminal. It gives you a different level, but you can see the height difference between these different ones, these different types of satellites. So most of these low Earth orbits kind of drive the latency down, really drive that. Okay, Jeremy? So I'm not really going to go through this. As you look through this, maybe go back and capture the slide presentation later, really gives you a view on how, on the left-hand side, it just depicts kind of the time. It's about 2,200 seconds when the rocket goes up and launches a payload, how it would go ahead and release a satellite. But it walks through, the left-hand side talks about how a satellite and the payload is released. The second slide on the right talks through how the rocket goes through, releases the payload, and returns back to Earth. And if you really want, the best thing to do is go to Starlink's site. They have some really good information on this. I actually have seen a launch at one time, so go ahead. Okay, so now let's think about the maximum subscribers that you can go ahead and support. So what I've done is I've gone back and looked at this, and so I just assumed that, you know, if you're kind of looking with the global satellites plan, and again, this is a little bit dated because, but this is, they have really today, they have about 3,900 satellites. You may recall, sometimes satellites just burn out early, which means they do not stay alive, right? They do not stay in communication. The estimate right now is about 3,900 active satellites, but what I've done is I've looked at capacity on the satellites and kind of looked at it globally and how those satellites go and the overall capacity that could be in the individual satellite system that's there today with the number of global systems. We've calculated. The bottom line is if you kind of look at the number of satellites and what's going on out there and the capacity that could be there, you know, how many users, how many active users could they support with a reliable level of usage. And really what this goes back and says, if you deploy those number of satellites, you look at what's going on, just do the math, you're going to support with a 4-to-1 oversubscription of about 4 million users on an instantaneous basis globally, right? Let's slide that, go to the next slide. So, but let's go ahead and look at the story. It's kind of looking at the US, right? So the map on the right really shows kind of a satellite space map. This shows, I've overlaid the United States, and it shows there's really less than about 100 of the currently deployed 2,000 satellites. It's really, like I said, 3,900, but even at then, the snapshot's still showing around 100 to 150. So I just assumed there's 100 active satellites over the US at one time. So what that means is if you kind of do the math on that and you calculate it, each satellite covers about 350,000 square miles. That's a big area, right? And so this kind of drives the actual capacity that can be delivered to an end user in the US. So if you assume the number of users, the capacity that's out there, visible satellites, what could it deliver, the capacity in gigabits per second, the number of users you could support. So in the US at any given time, to kind of give this type of payload, you can maybe support 20,000 users at an instantaneous time of 100 megabits per second. But then if you go back, let's take a look at what's happening with US carriers, because everybody says our satellites going to replace macro sites. In contrast, if we assume just the top 3 wireless carriers, and all of them have over 80,000 cell sites, the number is about 82,340. I can tell you the numbers. I've got them for all of them right now as of last month, but they're all around 82,000, between 80 and 82,000. So cell site provides just, on a low capacity assumption, cell site provides a minimum, if you assume the carriers deploy all the spectrum, 20 gigabits per second. That's with all 3 sectors going. The total US capacity for mobility usage at 100 megabits per second, the cell site operators can support 48,000 users simultaneously. And with an oversubscription means their 100,000+ subscribers that the carriers have today, 100 million, excuse me, should have no problem. And if you look at the full capacity per cell site on spectrum sold, using those same assumptions and the carriers deploying all their spectrum, they're going to be able to handle a lot more. So next. So even with Starlink and others, the real keynote here is that the need for macro towers isn't going away soon. As a matter of fact, we really don't see it. And the capability, if you really think what's happening in the wireless carriers, and we're going to be at 2030, and the data demands that are coming forward, the wireless carriers will probably be in the neighborhood of between 90 and 100,000 macro towers, as well as we'd expect 50 to 100,000 small cells just to kind of handle the baseline mobility traffic and the handset devices that we deploy today. And that does bring into some of the other devices. I mean, handsets are going to start talking to each other with a product line called SideLink. There's a lot of, autonomous cars coming forward. All those systems will enable the wireless networks and, the big 4, inclusive of Dish, but as well as all the other regional carriers that are out there today, including US Cellular and other companies that are out in those areas. Okay, so moving to the next slide. So the one thing I want to tell you that is a huge advantage of satellites, it's actually faster from a global connection, circuit connection than fiber. And let me explain why. So the satellites can also communicate with each other and they can create a path. So if you're looking at a global link and you're using a satellite communication and you want to go China to LA, that communication and that system is faster than using a fiber connection, undersea fiber connection from LA to China, because you use the least path of resistance of those satellites communicating. So there's an advantage where the global link is faster from satellite to satellite than a fiber system based on latency. Capacities may not be there for full model, but these systems can communicate satellite to satellite with that system, which is very, very interesting to look at. If you're looking at this global view, this gives you an idea of how the different constellations work together. And these, these satellites continually spiral in their orbits around the Earth to go ahead and make these circular models. Next. So like the key announcement we talked about, SpaceX and T-Mobile, the model of SpaceX, the authorization to launch 7,500 next generation satellites in orbit. Now remember, they said 7,500, the FCC approved 7,380. And that's inclusive of the ones that are already up there. The real thing is like, how could they do that, right? So if the only way T-Mobile could do this is they have their nationwide G-block license, right? So you have to have the same spectrum in the US to go ahead and communicate and allow this to happen. One thing that T-Mobile's been very clear about this launch is as we do this, this is going to give you text, but is it going to be real-time text? Not always, because of latency and delays. And you could see some delays, and so don't expect kind of the real-time model, but it does give you the communication capability. The nice thing about that is that band and that frequency is in all the T-Mobile devices today. So as SpaceX launches this, you'll have that capability as soon as the Generation 2 V2 satellites begin to beam and services really connect to the smartphones. So So the first level of the hardware, about 2,000 of those Generation 2 satellites will be equipped with this 1900 megahertz G band, which is 5x5. Okay, next. And that's just, I already said this, but about 96% of this is this is the band for G block. It's pretty interesting. The one other side note is on the satellite side, there's some proposed requests coming in from some of the other operator. Michael Dell has a satellite company in the 12 to 12.5 gigahertz band. They're asking the FCC to allow them to reconfigure that spectrum for satellite communication and along with an ancillary terrestrial component. What does that mean? Well, if you remember about 10, 15 years ago, for those of you that were active in the business, a company called, well, you had XM Radio and Sirius. So what they did is they originally had satellite radio, and they petitioned the FCC, which allowed them to have a satellite terrestrial component. What that means is, in some cases where they have, when that system first came out, if you would drive under a bridge or something, you'd lose your radio connection. The way they fixed that is they were allowed to take that satellite system and put it on a cell site that helped with some of those dead zones. What the Dell program and a few others, dishes in this too, want to do with that 12 gigahertz spectrum is to get a terrestrial component approved so they can actually deliver better service in some of those areas by reintroducing that satellite signal with the assistance of a terrestrial component or a cell site. So that's a new model. So the point is, satellite is not going away, and there's going to be more and more requests for satellite spectrum to kind of provide this mobility level of satellite assisting in that areas. Next slide. Yeah, that's the same thing I just said. That's okay. Next slide. The one thing to think about capacity is this is really what you're going to get. The satellite V2, the Starlink satellite V2s, you know, you're maybe going to get 2 to 4 megabits per cell zone. That's not enough. That's not enough for texting. Well, it is enough for texting and voicemails, but it's not really a big data system, as our data systems have a lot more. But these announcements, really, these are direct quotes from the T-Mobile team. Don't expect messages to go through at once. There'll be some delays. You're going to need full view of sky, because remember, these satellites usually have, if you look at Skylink, they got a fixed antenna. So your phone's going to be somewhat restricted. You're not going to be getting the satellite communication sitting in a coffee shop, and you could be delayed at time. But it is a good fail-safe, and it's going to be a nice thing to have. It will evolve. It's coming, but it's not a saving grace. I had a developer come to me one time and saying, well, we're really not going to deploy cell sites in anything in this new community because we think satellites are going to be able to drive it. Well, that's not right. It's not going to happen anytime soon. Okay, so next. We're just looking at more and more other things to come. We're really this Qualcomm Snapdragon chipset enabling satellite. The fact that Apple's come out with it is going to put more attention to it, and it will be nice as you go hiking or somewhere in an area to know that you could have a fail-safe, and that's what's pretty exciting about the satellite piece. It's your new emergency system. Okay, next, Jeremy. Look, key needs for the overall system. Anytime the U.S. will have 80 to 100 satellites. If they double the number, which they're talking about doing, maybe they'll have 160 to 200 satellites. This is about 314,000 square miles per satellite. Capacity at best per satellite is about 20 megabits per second. Downlink capacity limit, very minimal capacity based on that square mileage, and there could be some delay responses, especially as you start getting congestion on these systems. But again, it's working. People that have Starlink and have had the capability to get it are happy with it. And it's, is it a threat to what you have in your pocket? Not today, where you have service. In rural areas, I don't think it's going to be a threat. It's going to help, because carriers will continue to build out rurally, and they will continue to build out. Our industry spends about $30 billion a year in capital investment to improve their networks. If you listen to all the top CEOs of the wireless carriers, they're saying that number is not going to stop anytime soon. So, and watch somebody come out tomorrow and say they're not spending any more capital, but I don't expect it to stop. Okay, next slide.
That's it, brother. I think we
That's it?
made it.
Well, I think I have some appendix stuff in there, don't I, or do we remove it?
No, that's all I've got. The chat
Okay.
I didn't get much, but I'm on. So whenever these satellites go up into space, and I know there's, Starlink puts up however many go up at a time. What is the equivalent, say, cell site wise? Let's say there's 20 satellites going up. What is that equivalent to us, like on the ground? Like, does it take 20 or 30 satellites or 40 or I don't know the math, but let's say we have a conventional AT&T T-Mobile site or 4-carrier site. How much? What is the comparison between one satellite or
Well, so there's one way to look at it is capacity. The other way to look at it is square miles, right? And if you look at the average cell site from all the carriers and all, the average cell site covers about 2.5 mile radius, right? And that's some 8-9 mile rural sites, and that's some half-mile dense urban sites, right? So if you do the math, 5 by 5 is 25 square mile. Radius 2.5, double it. So 5 by 5 is roughly 25 square miles. You can see it could be a massive numbers from a pure coverage perspective. From a capacity perspective, and if you look at what's available, look, these wireless, by the way, that capacity should be 20 gigabits. That should not be megabits. That should be gigabits there. Can you fix that? If you're going to send this out, you make that gigabits. If you look at that, if you look at the cell sites and the average cell site capacity that a carrier is going to be delivered, we anticipate the fiber payload need per cell sites by 2026 to be about 50 gigabits per second to handle the spectrum that's out there. And then probably 20% of the cell sites by that time point are going to be probably 100 gig pipes. That's per carrier, right? So you can just see the difference in what 25 square miles is delivering versus 314,000 square miles. Massively different.
Crazy.
Yeah. Okay. Anything else on the chat? Or are we good?
No, I think we're good. I appreciate, Tony coming in today and talking to us about satellites. I hear people talking about it, at Texas, wireless events. I think it's good information. I mean, it's a good thing that it's happening. I think it's going to, cover some of those rural, remote areas, or places that have no coverage at all. But it's, I think Tony said, it's not a threat for us and kind of what we do. It's going to fill in some gaps that are needed for some, remote areas. But it's not like this is going to be the solution for Frisco, Texas, or Plano, or any of these places where we'd like to put another 30 towers in the morning.
Yeah, the biggest user of these systems right now are utilities for communication systems, SCADA, these emergency service systems, where bringing any kind of communication connectivity would just be tremendously expensive, right? And so as you talk to PG&E on the West Coast, you talk to Georgia Power in the Southeast here, these utilities do use these things for gas monitoring systems, and where they just can't get the cellular modem or the machine-to-machine type connectivity. So, okay, so Jeremy, one thing you recommend, probably good to the team for all those on the Texas Wireless Association, if you have topics and all you want to know about technology, 5G, what does it mean to us, how it's evolving, or other things, as Jeremy and the team is preparing these educational sessions, who do they send the notes into, Jeremy? Who do they ask, put those requests? Hey, it'd be great to have.
Send it to me, jbaldwin at diamondcomm.com, JBALDWIN at diamondcomm.com, and we're going to be doing one of these every quarter, trying to get more on bring some more value to Texas Wireless and our sponsors, that for people that may not be able to get to some of our events. We're just trying to bring some value to the members.
Okay, well, thanks for the opportunity. I appreciate it, and hope everybody has a great day that listened in. Yeah, any questions, shoot them over to Jeremy, and I can answer them, or a lot of people are shy on something like this, but I hope this helped, gave you some good visibility.
Thanks, guys. Have a good week.
You too.
Bye.